So what we're doing here, I'm going to kind of spill the beans a smidge early here since you saw the activity. We have been recording the meetings on the camera that I own, but it does not take an audio input. We were limited to the camera mic, which is not necessarily the best. And that, quite honestly, is an older camera, so the whole thing about it behind. So we're trying to experiment. Mark brought in one of these cameras that he has that actually you can control from your phone. You can zoom in, you can do a lot of stuff, which of course the one I have can't. So we're trying that as an experiment. We're having a little problem with the audio, so it's a camera mic as well this time. But the goal is to see if we can get a little better quality in our recordings that we're now putting out on the YouTube channel. So that's what we're doing here. If we find that this is good, then we'll decide if the club should buy a set for the club and have it look good. All right.
Take care, I'm in a meeting, so I have to go. Yeah, okay.
All right. Hello.
No, it's going to wait till 9 o'clock before we start.
I think you're good.
You got a program for 9 o'clock.
Rump roll.
I pretty much did. I was just a little work. It was working before.
That's what they all say.
You're right.
I got a bad dude.
The clock god is going, it's not 9 o'clock.
Battery in the remotes.
No, I think he just got his brain scrambled when I was moving around. Okay. It's 9 o'clock.
Perfect.
I planned it. All right, everybody, welcome to March.
I told you about getting close to that speaker.
You got close to me.
Is that what it is?
That's exactly what it is. Okay, welcome to our March meeting. First, I would like to introduce Wayne Paris. He's visiting for the first time. And hopefully he will become a repeat offender and be here all the time. And so, trivia time. Ready? The winner gets nothing. During the golden age of radio, what was the most popular show that was ever broadcast lasting more than 30 years?
How about your hit parade?
Amos and Andy.
Anyone else?
Susan Allen.
Amos and Andy.
All right. Pretty good, Reed.
You get bragging rights. Okay.
Wouldn't be able to do that now.
All right. Reminder, sign in. If you haven't, you will be punished. The minutes, I sent out the minutes earlier. I had an error on it. I misspelled Harry's name one place. And I added another thing, so I didn't go into detail about this experiment here, and that if it's successful, we'll buy some gear. So I did add that to the minutes, to the ones that I sent out the other day. But if everyone else is good with everything else, motion to pass?
So moved.
Move, second, third, fourth, great, love it. We're gonna go over some old business, we're gonna go over some new business. Mark. Member of the month. Lloyd knocked it out of the park, man. I don't know what you're going to do.
It's going to be tough act to follow. Yeah.
Pressure's on you. We'll have a break, and then Jim will talk about
Jim.
the Alexanderson. That's like 2 words. Alex.
What was his last name?
It was like that 2 last
He was
names.
a Swedish guy.
Alternator. We'll have open announcements. Then we'll do our show and tell. And I apologize. We didn't have the forms to fill out for the radios. That won't happen again. So I appreciate your ingenuity in doing that right there. And then we have some items for sale afterwards, if you're interested in such. Aries has brought in the club's tubes, if you're looking for something particular out of that set. Of course, those ones will go to the club.
Some of the clubs too.
Some of the clubs, that's right, because Paul brought in a whole gaggle of other.
Oh, there's more. When I was visiting Aries, he said, and now I'll show you the shed. And I said, the shed? Yeah, there's a shed.
So half a gaggle is here tonight to be purchased by. All right. Any questions on that? Good. Old business. You've seen it before, but I'm going to reiterate. We've got our YouTube channel out there. We've got our calendar. So if you go either to the Facebook side or the website, you can see, because I couldn't show this to you last time. You can see again what's out there, who's scheduled, whatever, blah, blah, blah. This does change, so if you're interested, go out there often. It is a work in progress. The Google Drive, so we've been starting to source all our content out there. We're in the process of moving a lot of the content from the website off of the website and having it live on the Google Drive. You still get to it, we're just changing links, but that way a lot of those documents will be living on the Google Drive and not on the web app, which is really the better way to do it. So that's what that top folder is. I moved over, 20 or 30 docs for Jim to start re-tagging. Facebook, we got 2 more members. If anyone saw the Facebook posting I did about the Ford display at the World's Fair, which piggybacked on Lloyd's presentation because he was there. I spoke to Ted. Ted is now one of these 86 people. He's not into radios, he's not a hand, he's not whatever, but he is kind of following this. I asked him, because he used to be the archivist for Coca-Cola, now he's the archivist for Ford. I asked him if he would, and he's agreed later in the year to do a presentation on Coca-Cola radios and on the whole Ford Philco thing. We'll do it with Zoom or Teams, because he's in the airport. Date TBD, it will be summertime or later. But hopefully that will come to pass, and that would be 2 very, very interesting presentations in my opinion. Because when I was at Coke, what you see at the World of Coke is a fraction of what they have. And you walk around in the basement, and there's just, stuff you've never even heard of. And there are a lot of radios. Now all they did was stick their name on a radio, but they were the kings of marketing, and radio sets were a marketing device, plus radio commercials and all kinds of stuff like that. And then also we've got the gentleman, Tim Richardson, who's an alderman in Ackworth, who knew about the club, and he said, hey, he's not been active, but he's joined up, and so he's kind of dipping his foot back in our water, so that's good. So slowly moving up. If you're not on Facebook, please get on Facebook. I'm posting all kinds of stupid stuff. Aries has got all kinds of interesting things. And Jim, I can't even discuss. Cards, we got them. Smoke them if you need them. So I've got a set here. You all want to grab a few. The idea would be obviously to swap me to pass them out, but there are some in here. We take them.
What are they?
Business cards.
Whose business?
Your business.
The radio club.
I didn't realize I was so popular. My goodness, this is fast.
So we got those. You can write your name, whatever, on the back, the front, and we made them very generic intentionally because, as I learned, the date of this meeting has changed over the years, the times, all of these things have changed. So we made them really, really, really generic. So all we have to do if we need more is go, print more. No editing, no nothing like that. I have some here you can take. I've got another box hidden. Again, certainly at the swap groups, take some pass away. So, oops. All right, on to new business. A couple of items. As you all probably heard, there's an event happening for the McKinseys on April 12th. I know Paul's been very up to date with a lot of that stuff. They're going to, as I said, have a service. I don't know if it's a celebrating life. I don't know exactly what the event is, but I know some people are going to attend. If you are because the 12th is also our meeting. So if you're coming to the meeting and with the intention of going to that activity, go, please. Don't feel bad if you have to leave early. I know Paul's going to leave early. If you need to just go there directly, But it is also the meeting day. So we're just being sensitive to the fact that some of you all may need to go to that instead, which is fine. It's totally cool. Swap meet. All right, you all know we got the contest back turned on, right? The radio contest. Well, after long pursuit and much arm twisting, we have 3 judges. 3 fabulous judges.
Yeah.
David Rush, who's going to be one of our judges. Jacob, and you all know Jacob was doing our presentation at that thing as well. So he's also going to be one of our judges. And that's good for a variety of reasons. One, it exposes him to more of us and to more of our broader circle of the hobby. Also allows me to start to use him to get into the schools a little bit more, so making some of those connections as well. But having him, he's also younger, and we certainly can do that too. So Jacob, having Jacob as a presenter is great. Having him as a judge is like super great. And then Dwight, who only thought he was retired from his presidency, is our third judge. And the beauty is, for the first time in how many years, you won't have to like do a lot of work. You just show up and slap an award on the radio and move on, right? Okay. So, thank you to everybody who's volunteered to do that. It's going to be great. And obviously keep going with that, but we've got the contest back, and now we've got good judges. Paul.
Do you want me to pull the plug on having the ribbons made?
No? What do you mean, pull the plug?
Get them to make them?
Yes. Pull the plug is turn off in my book. Yes, make
Oh,
it.
no, all right. So,
Yes,
I will.
yes, pull the plug, please. Yes. And so we have first, second, and third of the three categories, and then the best of show.
Plus the best of show.
Correct. Yep, exactly. All right, we've got a planning meeting scheduled for the end of March, where the officers will get together, fine-tune some stuff. We're looking for volunteers. If you volunteered last year and you enjoyed it, please do it this year. If you've never volunteered, it's a great opportunity to again, mingle with people and be part of the equation. We're going to need, just off the cuff, somebody to handle the 50-50 raffles, somebody at the front desk, set up and tear down. Last year, tear down was pretty chaotic. I think we've got a little bit of a padded window at the end, so hopefully tear down won't be quite as crazy. But certainly we need people to help tear down, because we do have to be out at a hard out.
We didn't need to tear down, that was the thing.
Yeah,
Oh yeah, you're right.
Because we were followed by a party, and they just said.
That's right, okay.
but we did sweep them up.
We did clean up, you're correct, so I stand corrected. Let's assume there's no party after us and we have to clean up.
We could party.
We can party. Bring the keg. So if you're interested in doing it, once we get our planning meeting wrapped up, I'll come back to you all and say, this is what we're looking for help. I'll send out an email. If anyone is interested, let me know. We'll slot you in and we'll go. And just remember, it's at the Fowler Park in the big, does that have a name? The big building, pretty nice building. Just go to the pretty building.
Yeah, it's the recreation center, and we're meeting in the community room.
Community room at the Recreation Center. Yeah, I didn't know the community room. All right. And then I'll start the advertising in earnest here pretty soon. And I'll make the flyer available to everybody, so if you all want to then go post to whatever channels or whatever social media you follow, you can do that too. Still looking for an admin to back me up, so when I win the lottery and I disappear, you're not hosed in social media. So I look to have somebody as a admin to myself, no work, no nothing, it's just really sort of a backup. I'm having to deal with an issue right now with another organization that my wife's heavily involved with, and I've done all of their social media. They had a Facebook site that we can't get into, we can't turn off, we don't even know who set it up. And unfortunately, it's still out there kind of snatching our traffic. And they actually posted some things the other day that were wrong, flat out wrong. And so the beauty here is that if I'm not available, the next person could make a fix, right? We can't fix this thing. I don't know how we're going to do it. So I'm trying to avoid that scenario, obviously. Member of the month, we're still looking for people. If you want to volunteer to give us your life story, if not, I'm going to start calling you, harassing you, and everything like that. Lloyd did an outstanding job last month. Mark is on the queue. Paul is going to do it next month, but given the McKinsey event, he's now, and then he's out on May, pushing him to June. So he's on the books for June. I could possibly do April or May, but it'll be the Lee Baker show for 5 hours. I don't think you need that. So if you're interested, let me know. If not, I'm going to start calling and playing.
Hey, you're doing well.
Hey, so far, anyway. I know it's hard to believe, but there actually was a time before radio. Ham radio operators had to use a hollow log and a club. Am I supposed to look this way? Oh, okay, sorry. Ham radio operators had to use a hollow log and a club. If you had two clubs, you could send the dits with one and DAS with the other, and that was the beginning of iambic keying for those hams among us.
That's your story and your story.
That was a bad joke of the day. Okay, but let's talk about the Alexanderson alternator. How did it work? How did it come to be? And what did it contribute to radio? We'll go back in time, but very, very briefly. Radio, the concept of radio has been around a very long time. Actually, during the American Civil War period, James Clerk Maxwell was a Scottish mathematician, actually defined and described a series of equations that predicted electromagnetic waves. A great deal was known about light in that era, but certainly not about radio or anything like that. But we still use those equations to this day. The problem was we could predict it, but how do you make it? No one actually knew how to make a radio wave until this young gentleman came along, Heinrich Hertz, who was a German college professor in classical education of his time, and he developed this device, a spark transmitter. And basically what you have is a DC source. They had batteries in those days, a switch, and what was called a Ruhmkorff coil. And what this is kind of like the spark coil. If you had the older ignition systems in our cars, the Kettering ignition systems, right? When you magnetize this coil, it opens those contacts. The contacts close, the field collapses, and there's a spike, a magnetic pulse, and a current is induced in the secondary, causing a spark across the spark gap. Now, a spark is a negative resistance, so it's actually capable of oscillating at radio frequencies. Hertz's receiver was a loop of wire and a spark gap. That was the weakness in Hertz's experiments. He never went beyond that. He had a series of different coils that he made. He actually had a micrometer built in that he could adjust the gap very carefully. He did a series of experiments with this thing and found out that you could actually bounce these waves off sheet metal, or you could block them with sheet metal. This apparatus operated somewhere around 1 meter, so he was actually the first guy to operate VHF. And spark transmitters were successful. They were employed at sea because if you think about ships at sea, once you leave port, they're out of communication. There's no way of communicating unless you actually have a visual on another ship where you can signal with flags or rockets at night or what have you, but otherwise they weren't in communication. So actually spark transmitters were quite successful for ships at sea and responsible for saving many lives. Of course, this is the Titanic. We all know about the story of the Titanic. And after that sinking, ships of a certain tonnage were required to have radio on board and operators that were available 24/7 while they were at sea. I think ships carrying more than 60 passengers and greater a certain tonnage. But sparks have an inherent problem. Sparks are actually a damp wave. They're not a continuous wave. So it's not like, you know, we're all familiar with the AC waveform. That is not what a spark transmitter puts out. It puts out a series of damped waves within the spark gap itself. And the problem with that is it's not a specific frequency. It's actually a broad band of frequencies. So a spark transmitter puts out very wide signal. You can't occupy other transmitters close by them like we do today. Also, the other big problem was, major problem, you can't modulate it with voice. So you can't send voice or music or data or anything as if data existed in those days. But you can't send that by a spark. A great deal of experimentation was done to do that. There were other competing technologies too of the day. This is the pulse and arc transmitter, named for the gentleman that developed it, a Danish engineer. And he developed this around 1903. And we can talk about this someday. It's kind of an interesting technology. What this basically is a big chamber, like a big cast iron chamber. And you have a fluid inside, typically alcohol, and the vapors vaporize above the pool of alcohol. It's closed to the atmosphere, and you have two electrodes down inside there that you energize, and it creates an arc plasma in the alcohol. But the alcohol doesn't burn because there's no oxygen inside of this thing. The problem with that is once you turn it on, you can't stop the arc, so you're not going to sit there keying. So they had some interesting ways of of actually modulating that continuous arc plasma. And we can talk about that some other day. But many of these were built, they were pretty big. This is a 1 megawatt generator that the US Navy actually used. Now, other people had an idea that alternators were well known. You could generate AC in the late 1800s. It was good, well-known technology. If you spun one fast enough, you create AC fast enough, you could actually create a radio wave. The trick was, well, how do you do it, right? If you look at alternators in your automobile, and if you have an internal combustion engine automobile made, since the late 50s, early 60s, it has an alternator in it, right? It's an AC generator. In the case of your car, it's 3-phase, and it's rectified with 6 diodes, and we put out DC. But in this case, you could actually produce AC radio wave. Now, a number of people were involved in that. Thomson in Europe, and Nikola Tesla, Siemens, and other famous people of the day. But they really couldn't get greater than 20 kilohertz. And it seems like Tesla was the winner at 15 kilohertz with his experimental design. And there were a number of people working on this. The man who made radio talk, this is Fessenden. He was Canadian born, he worked in the United States, and he actually did a great deal of experimentation. He worked with spark transmitters, trying to make spark transmitters talk, but they really were not successful. So he goes to General Electric and asks them to build an alternator capable of 100 kilohertz. That's really up there for an alternator. So he talks to Charles Steinmetz, who was the chief engineer. Where's Aries? Aries, you probably know about Steinmetz, right, at General Electric. He was the chief engineer. He was a German immigrant, had a classical education in Germany, and comes to the United States. He worked for General Electric. But he gets this young Ernst Alexanderson. He's a 26-year-old man. Now, this is not him at 26. He's about 40, I think, there. But he was born in Sweden, given a classical education at the Royal Institute in Sweden, went on to a technical college in Germany, and he emigrates to the United States and spent most of his time at General Electric and RCA. And let's talk about an alternator for a moment here. We'll segue here. An alternator is just a generator that produces AC, right? If you look at the old generators in a car, the reason that it put out DC is that when you spun the rotor, it went to a segment called a commutator, and that actually rectified it and made it DC. But if you don't rectify it, if you have slip rings, it actually produces AC. And all we need to do that is spin a magnet, cut across lines of wire, and voila, it produces a voltage. But the ones in your car and the ones that we have at power plants and such actually have wound rotors. And if you're going to do that at high speed, you can't have a wound rotor. You just, the thing won't tolerate very high speed. So, let's see, I hope I got the right next slide. Okay, if you're going to produce a 100 kilohertz wave, required a very, very special alternator. You're not going to sit there and spin magnetic windings. So instead, we have a rotor. Here's a rotor out of a 200 kilowatt alternator. And you see it looks like a smooth disc, because it is. There's no electrical connections to it. It's just going to sit there and spin in a field. And how could that possibly work? How is it going to generate AC? Well, here's the thing. That disc actually has narrow slots cut into it. And these little slots have a segment of steel between them, and that segment of steel is what's going to actually become your magnetic pole or magnetic domain. The slots only permit all of those little domains to exist. And in the case of these huge discs, I mean, these things are like 2 meters in diameter, so they're really pretty big. They would fill them in with a non-magnetic material, typically brass, because the permeability of brass is very, very low, right? Permeability of a vacuum is 1, permeability of air is like 1.001, and permeative brass is really down there as well. So actually the teeth are the important part, if you could call the steel between there, the teeth. And what we're going to do is surround that with a C-shaped stator. There's a tongue twister of the morning. A C-shaped stator. That's where the coils are actually going to exist. Here's a shot of the coils. And both the input coils and output coils are stationary on this alternator. So you have a primary coil that's energized by DC, has a continuous DC field around it, and then you have a pickup coil. A secondary is your pickup coil. And as the disc spins, and here's the disc, a segment of the disc, and here's your little magnetic domains here, the slots, they're going to spin past there, and they're going to alternately couple and decouple that field between the primary and the secondary. I mean, this is nothing short of genius on that man's part. So the outputs are connected to a transformer, since we're pretty much dealing with audio frequencies here. This is really VLF, I mean real VLF, very low frequency, to a transformer, and then the secondary of the transformer goes to your antenna. Very simple concept, right? Here's another shot of the thing. The actual frequency it produces is going to be the number of rotor poles times how fast you spin it. Right? So the faster you spin it, the higher the frequency. An alternator for 100 kilohertz, and I don't think anybody ever really achieved that. Fessenden wanted 100 kilohertz, and we're going to see that they had other lower frequencies. But for 100 kilohertz, you'd have 300 poles spun at 20,000 RPM. You imagine this 2-meter disc spinning at 20,000 RPM. Here's a cutaway view looking into it. This is the disc here. These are the coils, and here's the C part, right? The C stator. And that's spinning through those coils. The clearance, in order to have magnetic coupling between primary and secondary, had to be really minimal. So it was on the order of like 1 millimeter at these speeds. So it took a pretty stable physical design. Precision machining, certainly heavy, bulky equipment of its day. Now, since this was going to be a broadcast transmitter, you weren't going to move the frequency around rapidly. You wanted it to be a very stable frequency, right? You had some assigned frequency. So how do we do this? Well, we had a feedback loop built into these things. And if you'll notice, this is not an AC waveform. This is a response curve of a tuned circuit, right? And it's kind of like a slope detector. You'll recognize this out of an FM receiver that has slope detection. Some do. If this is the desired frequency, and you have a pickup coil fed to the tune circuit, as it goes lower in frequency, the voltage drops, right? Because you're detuning, you're off the tune frequency of that resonance circuit. If you go up in frequency, the voltage goes up. So now you've got a voltage that's proportional to speed. It's compared to a reference voltage and gives you a correction circuit. Actually, the ones that were actually built were designed between 10,000 meters and 24,000 meters, so really, really low frequency, 28 to 12 kilohertz. And of course, as we mentioned, it's determined by the number of poles on the rotor. There's a gearbox and a motor speed. We'll talk about the major components of this thing. But changing frequency, if desired, involved changing the motor speed. Right? If they said, well, okay, you used to broadcast here and now you broadcast there, you'd have to change the motor speed to do that. And certainly not a trivial task, because there's a great deal of mass involved in this thing. These rotors are humongous. You've got big gearbox, you've got big motors and such, which lends to the stability in and of itself anyway. Okay, so how's it constructed? You got 3 main parts, and here's the alternator itself. Here's a gearbox assembly in the drive motor and some ancillary equipment, the feedback mechanism of that. That was actually an Alexanderson 200 kilowatt motor alternator set for the Navy in New Brunswick, New Jersey. Okay. Now, how do you modulate a beast like this? How can you possibly modulate it? Because you can't just simply turn it on and off. You're not going to turn that big magnetic field on and off rapidly. And you also would like to voice modulate this thing. Well, there's a device called a magnetic amplifier, also known as a saturable core reactor. And they use these because you're going to modulate a 50 to 500 kilowatt transmitter. You're not going to put a key on this thing very easily anyway. So I have a very, very simplified, perhaps too simplified, diagram of a magnetic amplifier or saturable core reactor. In this case, what you see is if you have an AC source and it induces a field into the laminated core, and it produces some impedance here that holds back the current from that lamp. If we put a DC current through this thing, at some point it saturates the core, the impedance drops, right? And so the lamp would brighten. Well, in the case of the magnetic amplifier, it's a little bit different. You'd have a primary and a secondary, and the primary would excite this core. The secondary would pick that up and put it out to your antenna circuit, but then the control circuit here that you're modulating, whether by key or audio, would saturate or not saturate the core to a greater or lesser extent. I probably should have come up with a better illustration. But in any event, it's an amplifier because a relatively small current in the DC winding can control a great deal of current through the device itself. These were used in a lot of applications over the years. If you ever seen the theater lighting years ago, and when the theater lights would come down very slowly, like that was a magnetic amplifier that they were using to control theater lighting. The Soviets used them in their rockets because they didn't have SCRs and triacs. Today, of course, we use a triac in place of a magnetic amplifier. Okay, the advantage of this is it actually produced a continuous sinusoidal wave, so it's a pure waveform, pure AC waveform. There's really no harmonics to speak of, no distortion in the waveform, like the Polson arc converter, which we could talk about sometime, that was terribly distorted waveform and had a lot of harmonics, so that's why it never really took off. The signal was concentrated in one frequency, so all your power is one. You could have other stations next to you, near you, right? Plus, if you're listening to a given station, you want all the power in a very narrow waveform, because that's what you're going to actually be receiving. And it could achieve very high power levels. Some designs actually receive 500 kilowatts. And this is in the days when vacuum tubes were very, very small or non-existent. I mean, this started out before there were triodes and went up into the early era. And these were used for a long time, which we'll take a look at. There are disadvantages to the Alexanderson alternator as well. The weight, I mean, this thing is just gigantic. In order to make it mechanically stable, it had to be really big. SAQ in Grimeton, Sweden, which is still installed and still functional to this day, weighs 50 tons. They needed water cooling and oil cooling and lubrication of the bearings when you're spinning at a few thousand RPM. This is not 20,000 RPM, it's more like 2,000 RPM. But still, 2,000 RPM with a big mass like that. And it's really not suitable for marine applications. I don't know too many ships where you'd want to put a 50-ton transmitter on board a ship. Maybe Lee's yacht, perhaps. So it's pretty much limited to land-based shore stations, but for that application, it was successful. Okay, for some reason they were always built in pairs. Now the only thing I can see is probably for maintenance, that you could have one functional and one down for maintenance, alternating, because every installation I found were done in pairs. So there actually were 20 of the Alexanderson machines produced and over 10 examples. One of the big ones was New Brunswick, New Jersey, and Massachusetts. As you can see, a lot of these were on the Atlantic coast for marine operations, but some were elsewhere as well. And some lasted quite a long time. The New Brunswick one was installed in 1918, so pretty much during World War I, and it went out of service by 1948. So it competed very well against vacuum tubes, and then finally scrapped in '53. Same with Marion, Massachusetts, 1920, and then idled in '32. So it lasted 12 years, but it didn't get scrapped out until '69. They actually kept these in reserve. The U.S. Navy used these during World War II because it was so reliable and such a high-power situation, right? They had them in Warsaw. Warsaw was installed in '23. It was seized in September '39, for those of you who knew what was happening in September of '39 in Poland, and destroyed in '45 by the occupiers. And then Sweden, of course, is installed in '24 to '46, but there's still one in operation in Grimeton, and it's turned on normally twice a year. Reed has actually copied that by going to the shoreline, since CW, right, Reed? And they also turned it on once for their 100th anniversary. I think in 2024 they turned it on for their 100th anniversary. Actually, the Navy used them for a long time, but oddly enough, the Air Force used them. And why would the modern United States Air Force use them? Well, for Arctic communication, because communication with the Arctic is very unreliable at higher frequencies, right? Because of the degree of ionization at the poles of the Earth. But the VLF worked very well, and especially at these power levels. They put 7 of the originals back in alternator into service in '41, up to 200 kilowatts. So 200 kilowatt VLF is a heck of a station, right? They used them in Hawaii for communication with U.S. Navy in the Pacific during World War II. And let's see, in the late '40s, then the Air Force took control of the Hawaiian units, and also one up in Massachusetts. It's tremendously reliable communications. It was used also for submarine communication. There is one reputedly at the Smithsonian Institute, but it's not on display. I think it's in storage, and it's certainly not functional. Here's SAQ in Grimeton, Sweden. They operated, as I said, twice a year. This is the control panel, so you can see various Morse keys. And then this, you could pre-punch and send automatically, I guess you could say, that an operator could pre-punch a paper tape and then use that to key the transmitter. Okay, the 3 main parts of the device. Obviously the driving motor, you got to spin this thing up. A gearbox, this is a step-up gearbox instead of the usual step-down idea. So you could spin a motor at some reasonable speed and have the gearbox output at a couple thousand RPM. And of course the high-frequency alternator itself. In Sweden, they use a 500 horsepower motor. It runs at 2200 volts, 711.3 RPM. And oddly enough, and I haven't figured out why, the stator is 2-phase, but the rotor is 3-phase. I'm not sure why. You would think it'd be 3-phase and 3-phase, but oh well, what do I know? And then the speed control, you need big resistors, and the speed controls are these gigantic iron chambers that are actually resistors by having metal plates and water and mineral salts in the thing, and so they control the water levels, and that controls the resistor to give you the speed control. I think I got a shot at that too. It's worth seeing. Kind of cool. The gear drive, it's one humongous lubricated gear drive, and you know, for SAQ it's up to 2115 RPM, so that's really screaming along. Now the alternator. Now Alexanderson in Sweden, SAQ runs 17200 hertz, so 17.2 kilohertz. The steel disc is 1.6 meters in diameter and 7.5 centimeters thick. So this is a big hunk of iron, transformer steel. Right? You would want soft steel, soft iron, transformer iron. high silicon content. It has 488 of those slots that we talked about filled with brass, and their air gap is a little less than 1 millimeter. So each of the output windings, or those output coils, gives 100 volts at 30 amps. And let's see, I do the math on that thing, it comes out to 192 kilowatts, or pretty close to 200 kilowatts. And it operates today. They reduce the power when they do go on for commemorative operations at 80 kilowatts. Yeah, only 80 kilowatts. Here's the resistors. They have 3 of them, and to control the speed of rotation and so regulate the frequency of the device. But these things are big. They're like over 6 feet tall, big stainless steel electrodes, sodium carbonate for the electrolyte, and the liquid level is what controls the resistance. And then they keep a third one for backup, because I'm sure they need regular maintenance on these as well. The SAQ towers, the towers are not the antenna, and the horizontal wires are not the antenna. They actually have vertical wires hanging down, which really don't show up well, and I couldn't find any really good photographs, but they actually are phased vertical arrays. And here's a classic photograph of notables of the time. This is Charles Steinmetz, the German immigrant, who was quite brilliant in his own way. I mean, he was kind of like the second father of AC because of his developments that he made at General Electric. And of course, we know this guy who's coming to visit the GE plant and visit his colleague Steinmetz.
Really, Langner is in there too.
Yeah. And I'm sure there's quite a few other notables that are not credited. And of course, here's the feed lines going up to their antenna. If only I could have a station like that. Okay, any questions, comments, suggestions, rotten fruit? Anything, any questions about the Alexanderson alternator?
I heard that one of those antennas was 5 miles long.
The wires, yeah, between the length of the 6 towers. It's an incredible array. And a note about Steinmetz, his fraternity brothers nicknamed him Proteus. Proteus was a character in Greek mythology because he was the star outstanding pupil in their engineering classes in Germany. So they called him Proteus, and he picked that name up, Charles Proteus Steinmetz. That's it.
Is there any record of one of these things coming unglued, turning at those speeds with that kind of mass? You can imagine if it came apart, you'd have a...
Hey, these were built by General Electric.
Explosion, well, yeah. Anyway, I can just imagine how much...
Oh, at a couple thousand RPM, and
Yes.
it's hundreds of pounds.
Yeah, I built a 1 square meter loop antenna, preamp to a copy SAQ, at I think 19.2 kilohertz, you said 17.
17.2 is all documented, but
And Marty Reynolds and I drove down to the South Carolina beach where we could copy SAQ. It's fine on the beach. As soon as we moved inland to his estranged wife's house, the noise floor
yeah.
came up and it hid the signal.
Well, that's an interesting point because you can imagine the noise floor in the early 1900s was very low, right? I mean, basically what you had is an electrical depth distribution system at 60 hertz in the United States and a bunch of tungsten bulbs. What else was there, right? And then even later, I mean, you had radios, but that was often medium wave and high frequency and stuff. You didn't have wall warts plugged in, creating all kinds of garbage. You didn't have computer supplies creating garbage or the TVs. So.
There were switches.
I'm sorry, what was it?
dimmer switches.
Yeah, oh, dimmer, oh my God, yes, yes. Dimmers drive my radios crazy.
Because they're SCRs and they're switching on and off.
Wasn't for a long time a basic method of communication was submerged submarines, low frequency?
Yes,
Like-
ELF, yeah.
Like 60 kilohertz?
Yeah.
I remember my father talking about the Big Jim Creek antenna and transmitter up in northern Michigan that was
Yes.
like 5 miles long in order with vacuum tubes though,
Yeah.
to get signals of that. Now, the question is, are they still doing that? I think the Big Jim Creek thing was just,
No, from what I read about, that the antennas are all gone,
yeah.
and so they don't hail them. That was used for hailing, because you can imagine the bit rate is really, really low at VLF, right? I mean, all you're gonna do is send a hailing signal, and then the more modern submarines would send up a buoy and use satellite communication.
Well, yeah, I'm talking about 1940.
Sure,
Yeah.
yeah.
Which is,
I'm sorry, what?
dimmer switches.
Yeah, oh, dimmer, oh my God, yes, yes. Dimmers drive my radios crazy.
Because they're SCRs and they're switching on and off.
Wasn't for a long time a basic method of communication was submerged submarines, low frequency?
Yes,
Like-
ELF, yeah.
Like 60 kilohertz?
Yeah.
I remember my father talking about the Big Jim Creek antenna and transmitter up in northern Michigan that was
Yes.
like 5 miles long in order with vacuum tubes though,
Yeah.
to get signals of that. Now, the question is, are they still doing that? I think the Big Jim Creek thing was just,
No, from what I read about, that the antennas are all gone,
yeah.
and so they don't hail them. That was used for hailing, because you can imagine the bit rate is really, really low at VLF, right? I mean, all you're gonna do is send a hailing signal, and then the more modern submarines would send up a buoy and use satellite communication.
Well, yeah, I'm talking about 1940.
Sure,
Yeah.
yeah.
And
Ben?
From a historical point of view, there's something quite interesting about it. Because GE had these things and they were basically built in America, and it's at the time that they started becoming popular. The British were trying to establish a worldwide network, but they didn't have the technology, and GE wouldn't sell, or actually it was, what's it called?
Which is,
I'm sorry, what?
dimmer switches.
Yeah, oh, dimmer, oh my God, yes, yes. Dimmers drive my radios crazy.
Because they're SCRs and they're switching on and off.
wasn't for a long time a basic method of communication was submerged submarines, low frequency?
Yes,
Like-
ELF, yeah.
Like 60 kilohertz?
Yeah.
I remember my father talking about the Big Jim Creek antenna and transmitter up in northern Michigan that was
Yes.
like 5 miles long in order with vacuum tubes though,
Yeah.
to get signals of that. Now, the question is, are they still doing that? I think the Big Jim Creek thing was just,
No, from what I read about, that the antennas are all gone,
yeah.
and so they don't hail them. That was used for hailing, because you can imagine the bit rate is really, really low at VLF, right? I mean, all you're gonna do is send a hailing signal, and then the more modern submarines would send up a buoy and use satellite communication.
Well, yeah, I'm talking about 1940.
Sure,
Yeah.
yeah.
And
Ben?
From a historical point of view, there's something quite interesting about it. Because GE had these things and they were basically built in America, and it's at the time that they started becoming popular. The British were trying to establish a worldwide network, but they didn't have the technology, and GE wouldn't sell, or actually it was, what's it called, Wilson, who wouldn't allow them to sell the technology to Marconi. So the Brits were stuck with Coulson and spark generators for their worldwide thing. So that was kind of interesting. Yeah. Now, the brass bits that they put in there, presumably they would, I mean, you could just leave gaps,
Right.
but then you'd have a windage loss. From
Right.
the, sort of thing. The other thing, I mean, you talk about a 1 millimeter clearance on those things. I mean, you think of your aero engines flying around now with clearances smaller than that, and the things are much lighter and moving about the whole time. So,
Yeah.
I mean, it's not, nowadays, that sort of clearance at that sort of speed really isn't anything particularly that you would worry about.
I'm sure that's true, but in that era,
Yeah.
I think that was
Yeah.
pretty
And of course, you had a
amazing.
great chunk of material outside the disc, so that would provide some sort of containment.
Yeah.
I mean, how did the power of the driving motor relate to the power of the output of the transmitter? If you had a 100 kilowatt transmitter, do you need a 100 kilowatt motor? I don't know.
No, it really didn't, because it's only the spinning force.
Yeah.
The whole power is powering those magnets, the stationary magnets.
Yeah.
You have to put a bunch of power into those things. Because it's not 100% efficient, of course, nothing is 100% efficient. So you're drawing some amount of power away, like any transformer. Modern transformers are in the upper 90% efficiency. I don't know if this one necessarily was because of the coupling means.
What did they use for receivers, like in 1915, before vacuum tubes started to become practical? I mean, how
Yeah.
would you receive?
Magnetic detectors. They had magnetic detectors, which is like imagine a clockwork, okay? And we have a band of magnetized steel, soft steel. And you wind it up in the morning, right? Maybe you rewind it in the afternoon, and it goes through like this. You have coils that bias it very much like a tape recorder. And then you put your antenna signal into that, and you have another one out, and voila, it gives you a detected signal. That's what MGY, the Titanic, used. They used to wind it a couple times a day.
Well, in that research I did for the presentation I made about
Yeah.
vacuum tubes, in 1920, when they formed RCA, from a commercial communication standpoint, all those generators pretty much went somewhere else. And the point is, I never followed the track of what happened to those Alexanderson generators.
Well, they kept them.
Yeah, I understand they
Yeah.
did. The point is, though, that when vacuum tubes took over, and by even 1925,
Right.
vacuum tubes were it.
Yeah.
And
But the vacuum tubes that were were mainly used for broadcast at that point. They didn't really need it down at 17 or 20
no, and
kilohertz.
that's why they moved to the upper frequencies.
Right.
But it's really interesting that those generators maintained operation
Yeah.
for so long, and that's something that had completely escaped.
Yeah, the Air
anything
Force
I've
used it
ever
up
seen.
till, what, 1957? So-
How the hell would you receive a signal at 30,000 feet in an airplane at 12 kilohertz?
Oh, I don't think it was intended for that. It was the Arctic bases, the research bases.
All right, okay.
And there, I mean, Reed did it with a loop antenna, and they may well have done loop antennas or equivalents, or voltage probe or whatever.
Okay. Only a small number of the people in the air.
And it is, doesn't say a lot of export stuff.
It's a Philco 49501. I think most people call it the Jetsons radio. Yeah.
That's really pretty. Typical what you bring in all the time. As soon as I seen it, I said, I don't know who's it. Very fast, like LOL. I'll hold you technically first. I will. I don't know the model of this one, this is mine. He's running away. This is my radio, this real Art Deco. And it's kind of rare, I guess, in some ways. I haven't seen many Admirals. But it's a little dirty, sitting on the shelf for several years. But it's pretty. Bought the dial cover from mine. Anyways, there it is. Nice one, pretty cool Admiral 1950s. And here we have Bill Cook. pretty good load.
My wife and I made a recent visit to Spain for work and pleasure, and we bought that at an open air market. They wanted $100 for it. My wife negotiated it down to 40, and I wagged that through TSA as a carry-on in a bag, and it went down the belt. And I saw the screen, and the transformer was flashing red, and I had to describe what it was. I explained it's an antique, blah, blah, blah. Anyway, long story short, it's a 220 volts. Transformer looks pretty standard as far as the tube settings and all that, but any advice on what I can do to work on this?
A transformer that puts out 220 from 110.
And just step up from 110 to 220?
Yeah, you just need a 110 to 220 step-up transformer.
Yeah, they're pretty.
Sometimes, because I've got a British-made one, and the transformer is taps.
Yeah. This
So you should
Oh.
look at the transformer, see if there's taps for 110 and 220.
I'll
That's a good
definitely
point.
that one is definitely made in Spain.
Yeah.
And if you get a chance to take a look at it, the dial has all of the European
Station.
cities and country. It's just an amazing radio, and I just had to have it. But I wanted to share that. So.
You may have a searchable transformer.
And I don't even know what the brand is. I couldn't really find a brand on it. So maybe I can use Amazon, what is it, where you take a picture of it and it'll tell you the name.
You got the model number.
Is it not in the radio museum?
I probably should go look, but
Yeah.
how do I do a search on that?
Just go for radio museum and look for
Hundreds,
Spain radio.
Spain radios maybe?
If you've got a model number, you can just try typing in the
Yeah.
model number.
Did you see a model number?
I think
Yes, there is a model number.
Okay.
I'm sure Google image search.
You got Google it, yeah.
Key into
That could work.
the radio museum.
Around the 800 to 811 and 820. And that's the bigger model.
You can take the back off and take a look at it. It's just really easy.
Around, they show a water faucet.
Yeah. Well, that'll do it.
Yeah, proper body.
No, I don't need it.
No, there's no documentation.
I would just buy a transformer for it. Step up.
Thank you.
Next one's mine, 1942 Zenith 7G605 bomber radio. It's in really, really good shape. I got it for, it's still expensive, but much cheaper than the rest of the world. Roger put his magic to it. Works pretty darn well, though I'm in a radio black hole in my house. So my 100-foot of wire in the backyard, I still can't pick up a spot. Barely get WSP. But what's interesting about that is, you know, they used to sell little tags with instructions that you put your name and your phone number and stuff on it. That has a tag. The name is Henry Abrams. He was in a group in the Second World War in Europe that would go through, and it was part of a construction thing, so they do bridges and things, and he was responsible for mess halls. And he actually got accommodations for setting up mess halls. I found his house that he lived in, because in this book was like a yearbook where he was mentioned, he had his residence. I found his house. It was there, still there, and people live in it. But I haven't been able to get any more detail about him. My wife is big into genealogy and has access to all that stuff. I just got to get her to get into the military records, which I can't get to as Joe Average. But I'd really like to find out if his family is still around. And I toyed with, contacting them if I can, and even offering it up to them if the family's around. But it's cool. I have a name of a person who had that, and it was in Company C, and it was listed in wherever the heck he was in Germany or whatever he was doing that. And I said, I've seen his house, it's a cute little house, and it'd be really cool to see if his family's still around.
Where was his house?
It's in New York.
New York State.
New York State, or was it in, because I had two I was chasing down. One was in New York State, and one was in the Midwest. So I actually don't remember now.
Did you say you know the year it was made?
That's cool.
The radio, I'm assuming 42 because everything I saw was they started making those with the sailboats at the very end of 41 and in spring of 42, Siemens stopped making radios for commercial use and went to all the way to that.
They made 500 and some special translucent annex for the military.
Yeah. That's not the military one, that's just.
No, it was the later ones that they used. It's got octo tubes, it's got a mixture of octals in it. And some of the tubes are like 1947, so they're replacement sockets.
Roger got it working, cleaned it all up, so the switches were a little misbehaving, but we made them
When
cooperate.
you put up the antenna here, it's switches
Yep. Between the,
to the external antenna with the switch here.
I've never seen one in that kind of condition.
I know. It's really
That is a rare
Pretty
piece.
pristine. I've done nothing other than just clean it outside a little bit. Roger did the stuff on the inside. I tried to soften up the suction cups. I heard a story that you can soak in the WD-40. Well, that doesn't work. So that's probably one part. And I actually thought about buying, you can get a reproduction of the battery that would go in there. You can put common cells in it.
I sold
And I thought about buying one and stick it in there just for common cells.
I sold one to a guy one time, and he took it to Florida. He used to live in Alpharetta, and when they had my store at Main Street. And then he brought it back from Florida for me to make it battery operated, and I made it battery operated also, so he could take it to the beach in Florida and show off a little bit. Yeah. I mean, it's not hard to do. You can put your, and I see, this is probably for the lights too there.
I've never,
The D cell's for a Darwin.
Yeah.
It's for a Darwin.
Yeah.
if I had a radio like that,
I
I'd never
had one
take
that
it.
one time that had the original Zenith battery, and I took it apart.
Yeah. Yeah, I got
I
one
stuffed
of the
it.
battery packs on the shelf at
Yeah.
home. I used to have one of those.
Never take it into a salt air atmosphere. Oof.
Well, we didn't take it out there very long, but
I know, but it's still,
we
you
just show
know.
off of it. Hopefully, no water would splash near it. Okay. here we go.
So this one's mine, it's a Manitola. And I had a really hard time finding any information on it. I finally found out that the sequence went from Manitola to be a Goodrich to ultimately Continental, who probably made it. And that's who's a schematic I actually matched up with that. I got it at Cutstown last year for about 20 bucks. So it refinished really, really nice. I added Bluetooth to it. So it plays really well. Really happy with it.
See your little Bluetooth transfer.
Yeah, I made a little package for the back, and because that had a lot of room inside there.
Yeah.
So in there is a power supply for the Bluetooth and the Bluetooth itself.
And it doesn't get into the receiver bed?
You know,
Usually switch mode transformer and all that, when you get the Bluetooth thing next to the radio,
now probably because it's a little ways away from it, and
I always put them at Sterling, put a 3.5 jack on the back, so I can get it away from the radio.
yeah.
You know, that would be a good topic for a presentation. How do you Bluetooth a radio, and what do you do with the various types of radios? How do you get the power and everything? And you showed me a neat little package you put together.
Yeah, well, YouTube made it first.
Yeah, but that's all right. The point is to let everybody know.
Because you use a cube, right, break it apart,
Yeah.
you got the circuit board, you even got the connector for your power supply, just cut the two, you just use the black and the red over to your Bluetooth board, and
Make a
yeah, that's it
presentation,
right there.
make a presentation out of it.
So what he's doing, taking the power supply, right?
Everything is in that little box there.
Got the audio going back
We
in.
got another
Yeah.
subject. for
And it's
the
easy on these because of the fact you got a power transformer, so you're not worried about isolation.
Right, right. Plus there's room in there for it too.
Plus you're all set this way. And you just go on the high side and line.
Yes.
A number of times people have mentioned Cube this morning. Cube?
Yeah, for like a USB cube for 110 that you plug into the wall.
Oh, it doesn't even like a wall.
Yeah, you just break it apart, they come apart easily, and that, your circuit board is there.
Oh, yeah.
So that gives you your 5 volts that you need for the Bluetooth.
Just didn't recognize Cube.
Yeah.
Yeah, well, all the stuff that I do for customers mid-century modern consoles and stuff that I do. I buy these little rechargeable ones from China that cost me about $2 or $3. And I charge them up and I give them to them and they can recharge them with USB.
Yeah, the Bluetooth
All I
was
do it with a 3.5 cable and
from China, obviously, but
Yeah.
I think it was like
I don't
a
use
5-pack for like about $12.
yeah, mine were only like not even 2 inches long. Like,
Yeah, just the little tiny things.
Yeah.
I had a hard time soldering because of
But
where you solder is really, really tiny.
Yeah.
Who's next?
And what we got here is Gene, the dancing machine.
Well, this is as far as I know, it is a Howard 902W. I guess the W stands for wood. And I've got a funny story to tell about this one. I was at a Western Carolina Ham Fest about 40 years ago. And at that time, they held the Ham Fest right next to the flea market in Fletcher, North Carolina, which is a suburb of Asheville. And after the Ham Fest, I was looking around in the flea market, and here was this little radio. I kind of felt sorry for it. The elderly lady was selling all this stuff, and she said, I'll let you have it for, I think it was $10 or $11 or something. She says, I'll tell you one thing though, right now, it don't have much volume. And so I said, well, you know, for $11, that's a good deal. So I thought it was cute and I took it home. And it got christened Little Howard because it's a little radio and it's compared to some of them that I have. And it says Howard on the front, so it was Little Howard. And I took it apart and found out why it did not play very well. Somebody had replaced the speaker, and apparently the speaker they took out had an integral audio output transformer on it, and whoever replaced the speaker just tied the speaker directly to the plate of the 5006. And I know that little tube was real happy when I put an audio output transformer on it, and it played pretty well. At least it'll pick up WSB. And I refinished the cabinet or cleaned it up. I didn't really refinish it. I just cleaned it up, put some oil on it. It was pretty dirty. And so that's the story of Little Howard.
Good. Yeah, original back even.
Yeah, I've got the original back, and it's got I thought maybe it was earlier than 46, but it's got some parts in it that look like they're from before the war, and they probably are because I don't believe they made any broadcast, commercial broadcast radios for about 3 or 4 years there.
Sometimes you can get a pretty good date if you can find some of the original tubes and read the date code.
Yeah, it's got some, looks like dog bone resistors and stuff in there, so I thought maybe some of the parts, the radio may be a 46 model, but it's probably got some pre-war parts in it.
Yeah.
Here you go, Roger.
Oh, no. Give
Thank you.
Jim the electrician. He's got a hippo or a hippo.
Yeah, the hippo, the Philco.
You a hippie or a
46
hippo?
Yeah. I got that from my father-in-law, and that sat on his workbench in his barn for God only knows how many years. But every time he painted something, a little bit of the overspray or brush or whatever went into it. So it probably had 40 different colors on it when I got it. But I cleaned it up, polished it up, and it plays well.
Yeah. Recapped it and all that stuff.
Yeah, recapped it, and it does okay.
Yeah, you got one original cap there across your foil.
Well, I had to keep that for, memorial.
Should have restored. Yeah, these are kind of neat because of even the way the dial works. And if you get the radio out of there, you got to unclip it.
Yeah, it's kind of a pain, but
Yeah. nice radio. And you are missing the back.
Yeah. But the price was right.
Now, somebody's got the diagram and
Here
everything.
we go, Reed.
We've got the diagram and all.
Let me refresh my memory, so I know what I'm talking about. Let's see, something dropped on the floor.
Just power supply.
Am I still transmitting? Yes.
Bounce test.
This is a Teletone 109 radio.
Got some paperwork left.
A little bit of tag there. Yeah, this is a DeWalt A500 from 1946. This is one of those kind of radios where I buy and then just put it on the shelf because I haven't had time to take it down and work on it. But I like the, I guess you call it the Plascon, ivory Plascon. It's got a nice patina to it. And eventually I'll tear into it and recap it. But I was trying to find some information on this particular model on the internet last night. Didn't see a whole lot out there. They made this, of course, in a brown bakelite, but could not find any pictures of the ivory. So it might be kind of a unique one.
It says it's an A500. ACDC.
Thank you, Dwight. Thank you, everybody. While you were doing that, I was multitasking, because that's what I do. On OCD. Henry Abrams, one of that radio. Omaha, Nebraska. That is not his house.
Looks like Nebraska, yeah.
Well,
Like the ex-Navy guys that took care of wars.
are you serious or being facetious? Because that could go either
He
way.
did it out of a Petri dish, so he could.
Maybe so.
Clear styrene.
Yeah, well, anyway, if whoever wants the jewel cases and the CDs are more than welcome to that. I'll go over to tee up the other stuff first. Next meeting, 12th, 9 a.m. I realize some may be attending Mackenzie's event, that's fine as well. Show and tell. This is going to be interesting. Upside down chassis and cardboard radios. I don't even want to know what a cardboard radio is. That's not going to last in the bathtub here. Presentation, we're still working out. So if anyone has something they would like to present, let me know. Otherwise, I'm going to draft somebody. I could also do it then, but because I'm going to do at some point a presentation on the history of television graphics. And I'm also going to do another presentation on the history of videotape because I'm like just that old. But I don't have those. I like to do those later in the year, but you all may get stuck with one of those next month if somebody else doesn't. And member of the month. We're still looking for a member of the month. I kept joking it would be the Lee Baker Day because I could do member of the month and the presentation. But you really want 2.5 hours of me up here? I don't think so. So, if you're interested, member of the month, let me know. I'm going to start calling people if I don't get any responses. And then if you have a technical presentation you'd like to do, let me know about it again. This could be the Lee Baker Day. Any thoughts, any opinions? Any questions? Any complaints? If there are complaints, tell Jim. I notice these meetings are running a little shorter than historically they've been doing. If there's more content that we should do, if we're okay.
For the business side, it's been shorter.
Business side has been shorter because the business has been shorter. I can make stuff up, but my bad.
Maybe we have it reserved like.
So you want to see what I got?
We could do that. We could do that. I know Dwight was really good at connecting his presentations to the theme, so I could have that, or just do one anyway.
On the 12th, you're gonna be looking forward to the swap.
Right, that'll be a lot of content.
There's gonna be a lot of content.
But I'm just talking in general. Next month, there'll be a lot of detail on the swap meet, and hopefully we'll have our assignments, et cetera.